Okay, sorry, my computer had like some issues, so I had to relog like log in again.
Okay.
Yeah.
Okay, so let's start. We're starting with the F. Up to F we discussed in the organic reaction. Now we start with G. Okay. Now you will do this G question.
Okay. Oh my God, what is going on? Oh, sorry, not it. Sorry, I wasn't saying that to you. It's just my computer is behaving so weirdly today. I don't know. Okay. Do you want me to do G?
Yeah. Any doubt? Any issue?
No, I'm just going back to my notes from yesterday.
Okay.
So
Okay.
yeah, I just so
Hmm.
basically for the what I did is like I just flipped the dash to a wedge for OH, right?
Mm,
Is that what it is?
So what SOCl2? What is SOCl2 first you tell?
Thionyl chloride.
Thionyl fluoride. Okay. And what SOCl2 will do in presence of pyridine?
Mm-hmm. It will attack the chiral carbon. Like
Okay.
the yeah,
And
and then change the configuration.
change the configuration by inverting the product or
Inverting, yeah.
not.
Inverting, yeah.
Okay. So what will be the product? Cl will come, and what type of the reaction? Like, is it elimination? Is it a substitution, or what type?
It would be SN2.
SN2. Yeah, SN2. Great. So see, wherever SOCl2 will come, thionyl chloride will come with pyridine, then in that case, always SN2 will proceed. Okay. Now in this case, Walden inversion will take place. Okay, and this is the product. In SN2 reaction, is there any sort of like intermediate present or not?
No,
No. Then
no. Well, I think it's just the direct product.
yeah. Okay. So this is the product in case of SN2. Now you proceed with H reaction. What is this reaction like? What sort of functional group in the reactant side here?
Uh, the functional group, you have the benzene, right?
Benzene and no, I'm asking
And
about
hydroxyl.
hydroxyl, or we can say
You,
alcohol.
yeah.
and H3PO4. What is H3PO4?
I'm gonna go back into my notes again. Okay, H3PO4, it's going to be H3PO4, H3PO4. I don't know if I have that in my notes. Hold on. I have SOCl2, pyridine, then H2SO4, then POCl3, pyridine, HBr. I don't think I have that actually in my notes.
H3PO4 is a type of acid.
Oh yeah, acid. Okay, yeah.
Acid.
Because of
And
that H3,
yeah,
yeah.
and it donate H positive ion. Okay. And H3PO4 is a strongest dehydrating agent. Strongest dehydrating agent. What is a dehydrating agent means?
Removing hydrogen.
Hmm?
Removing hydrogen.
Only
Or dehydrate. Because,
dehydrate. Yeah,
yeah, because
of, like
water, right?
water. Yes. So removal of H2O is dehydrating. Okay. So H3PO4, and there is one more reagent you can also write down. You can take a note that P2O5 and H3PO4 and H2SO4 in concentrated manner. Okay, all of these are work as dehydrating agent. Okay, you can take a note for this part. Okay, now there is a dehydrating agent and there is a H positive ion present. So what this H positive will do? Tell me.
Um, okay, if it's H plus, then it's gonna be, I think E E1.
Great.
Yeah.
Yeah, even. So what is the next process? What is even reaction?
E1, it's a bimolecular elimination, which means it occurs in one
Mm-hmm.
step, and there's a carbocation intermediate, which can also be rearranged
Great.
to form the product. Yeah.
So after this, the lone pair of oxygen will attack on H positive, yes or no?
Mm-hmm.
Then what will be the product in this case? I'm writing here. So like this, and here is OH2 positive will come, yes or no?
Mm-hmm.
Then what is next step? Hmm?
Then what will
OH2,
happen?
whenever OH2 will come,
Yeah.
then there is always dehydration will take place. Okay. And if there is a
Yeah.
dehydration will take place, then a carbocation will form. Now
Mm-hmm.
you tell me, is there any rearrangement possible in this carbocation? And also tell me what sort of carbocation it is. This is very important.
Yeah. That one's secondary.
Secondary, yeah. And there is one more, there is two terms which we discussed in previous class. That the first is vinylic
Primary.
alcohol
Oh,
and
vanilla.
allylic. So what is the major difference in between vinylic and allylic? Can you tell me?
The major difference, lilac is a carbon that's attached to an sp3 carbon that's then attached to sp2, whereas vinylic is attached directly to sp2.
Yeah, great. So what type of carbocation this is? Is it allylic or is it vinylic? Hmm,
Uh, I think it's a lilac.
great. This is allylic. Now, allylic carbocation is most stable carbocation we can say. Okay, allylic carbon is more stable. Allylic is
Mm-hmm.
more stable as compared to 3 degree also. Okay,
Mm-hmm.
so this is allylic carbocation, and after that allylic carbocation, there is no any like any rearrangement will possible. Okay, so after this there is a hydrogen. So even reaction will proceed. Even reaction means elimination. One hydrogen will remove, and this will be the product. Okay, this hydrogen will remove because this is an elimination reaction now.
Yeah.
Mhm. Any doubt up to now? This complex is known as styrene. Okay.
Mm-hmm.
Whenever there is a ethene group attached to a benzene, then that particular compound known as styrene. Okay,
Mm-hmm.
great. Any doubt in this reaction? What is H3O4? H3PO4, sorry.
Wait, where did the hydride shift
Hmm.
happen? Oh, okay, okay. I see hydride shift.
In this case, there is no hydride shift will be there in this
Oh, but
reaction.
then what's the hydrogen that you oh
Huh?
wait. Because you wrote like when the one the second to last one, not the last one, there's like a hydrogen, or is that just like a not important hydrogen that you drew?
Where? Okay, so in here in nearby to H3PO4, this one?
No. I don't know if you'll be able to see me annotating this one.
No,
Can you
no,
see
no.
me?
Your annotation not working.
Oh my God.
Yeah. Visible, visible. Here. Yeah.
Yeah.
Okay, so this hydrogen, this is not a hydride shift. This is elimination reaction. Let's suppose I have here, you see here. Let's suppose I am having a hydrogen over here and a one positive charge over here. Here. Okay, so in that case, what will happen? There is a elimination reaction will take place. This bond will shift over here. Okay, and it will converting into this one, double bond. This is elimination reaction basically when some element will remove. Okay,
Mm-hmm.
any doubt?
Mm,
Let's suppose I have one more example. If I have there is two element. There is one OH and one is hydrogen over here. So in this case, we need the dehydration again. So what will be the process here? This OH and this hydrogen will eliminate.
mm-hmm.
Okay, eliminate how? Like this. Okay, and there will be a double bond comes. This is an elimination reaction. Whenever there is a single bond converting into double bond or a double bond converting into triple bond, so in that case, elimination reaction will proceed. So what is even
Mm-hmm.
reaction? Even reaction E stand for elimination. One
Mm-hmm.
means there is one step will be there, one carbocation will be formed over there. Okay, so in
Mm-hmm.
this in even reaction, always a carbocation will form and at the nearby carbon, there must be a hydrogen present. So, with the help of that hydrogen, the elimination will proceed.
Mm-hmm.
Hmm. Now tell me. Now tell me one more thing that let's suppose there is not any hydrogen on the adjacent carbocation.
Mm-hmm.
So, in that case, what will be the process? How we can proceed elimination?
If there's no, sorry, can you say that again?
See in this reaction where the
Mm-hmm.
carbocation is formed. Okay, and there is a
Mm-hmm.
hydrogen which shifts the single bonds to the nearby carbocation. Okay, but if there
Mm-hmm.
is no any hydrogen, so in that case, what will be the further process? Is the reaction will proceed at that point?
If there's no way to rearrange, then no,
Yeah,
because
great.
it has to be stable.
Yeah.
Mm-hmm.
If there is a stability, then the reaction will stop over there.
Mm-hmm.
Great. Okay. Any doubt? What is H3PO4? What will H3PO4 will do in this reaction?
No, I know that's an asset. I think I should have been able to tell. I was like kind of overthinking, but it's kind of obvious it's an asset. I was gonna ask more like a question about the stability in terms of like primary, secondary, tertiary, right? So if you can't make tertiary, is secondary still like somewhat favorable, or you like can the reaction still go as not stable?
Please, the most stable part is allylic carbocation, then 3 degree carbocation, then 2 degree, and then 1 degree. This is the stability order of carbocation.
Okay.
Okay, stability
Mhm.
order of carbocation. Then there is one more thing that see sometimes okay. So whenever rearrangement is possible, so there is two possibility that the stable that after rearrangement. Wait a second. Okay. So there is two possibility in rearrangement. There is two possibility in rearrangement that after one rearrangement or one shift, the compound will be stable. Okay. And there
Mhm.
is also a possibility that after two or three shifts, the compound will stable. Okay. This is also possible now.
Mhm.
So, in case of carbocation, we only proceed with that rearrangement that will give the stability in first step. Let's suppose there is a 3 degree carbocation, firstly.
Mhm.
Okay. In the first step, I am having a 3 degree carbocation. 3 degree carbocation. Okay. 3 degree carbocation.
Mhm.
And after a 1,2 hydride shift, it will converting into a 2 degree carbocation, and after again 1,2 hydride shift it will converting into allylic carbocation. So what do you think about this? Is the process is like stable or not, like the carbocation which formed in the last is stable or not? In the starting I have
Uh-huh.
a 3 degree carbocation, then after 1,2 hydride shift it will converting into 2 degree carbocation. Okay.
Mhm.
And after let's suppose any sort of shift will be there, so after that shift it will converting into a allylic carbocation. Okay. How many
Mhm.
carbocation will form during the reaction? Three. The first is 3 degree, the second is 2 degree, and then allylic. Okay. So now the
Mhm.
term will come that is the reaction proceeds or not, is all the three
Mhm.
carbocation will formed or not. So in this case there is one major thing which we need to know, that in case of carbocation we only saw one shift. Okay, we only saw one shift. Is there any stability after one shift will be there? So in only that case the carbocation will rearrange. Okay, we didn't see that like after three or four a rearrangement the carbocation will stable more. Okay, do you understand?
So
No.
this is just all in one. Is that
Hmm?
so you're saying like okay, I see what you mean. Because we didn't have two or three shifts, right? It was just in one.
No, there is the possibility of two or three shift, but after each shift, the carbohydrate needs to be more stable.
Okay.
Okay, note you.
Okay, yeah.
This is very important thing.
Okay.
After each shift, carbocation needs to be more stable. Okay.
Mm-hmm.
Okay. So this is the stability of carbocation. Do you have any doubt in this one?
No, not really.
Mhm. So let's. What is styrene?
Kyrene. I don't think you've taught me this, man, but I also don't know from before either, so I don't know.
Here is the styrene.
Have you taught me it or no?
Here is.
Oh,
See.
styrene. I think you said tyrene. Sorry, that was like something else. Sorry. Oh, styrene.
Hmm.
Did we talk about this before? Is it just like an alkene?
This is a alkene which is on the benzene. This is
Okay.
very useful in polymer industry.
Oh, okay.
This is very useful. This is
Oh, styrene and plastic and stuff?
yeah,
Okay,
yes.
okay.
It used to form a lot of materials which is like needed a strength like parachute
Mhm.
and all. So this is very useful. Okay. Now let's move to the I question, that is this one, and one OH over here and here. This is the reaction. POCl3 and pyridine. Now this reaction needs to solve. Okay. Try this one. Hmm?
Oh
Try
no,
that.
sorry.
Yeah.
Oh, sorry, you were talking to me.
Yeah.
Oh, sorry, I was just folding my paper that I had. Okay.
What is POCl3?
Phosphogen, I think you told me phosphogen. Okay. Phosphorus oxygen trichloride.
Hmm. Yeah.
Yeah.
So whenever there is a POCl3 in presence of pyridine, then what type of reaction will proceed? Hmm?
What type of reaction will proceed? E2.
E2. Very good. POCl3 in presence of pyridine. And then SOCl2 in presence of pyridine in that case?
SOCl3, it's
SOCl2.
sorry, SOCl2.
Yeah.
Uh, SOCl2, it's going to be SN2, right?
Yeah. Great. So now you are aware about reagent. So you can proceed with the product. Now you tell me what will be the product in this case.
This one would be E2, right? So the main, oh, and then for E2, I remember there was like a condition, right, for E2, where it was like there's certain exceptions for, oh no, that was for epoxide. Sorry, I don't know what I'm saying. For E2, it would just be direct product.
Yeah.
Yeah.
Direct product, but direct product on which direction? See, how you generate the direct product in this case. Can you draw?
Mm, oh, okay. Yeah, I can try to draw it.
Hmm.
Yeah, I'm gonna draw right now. Sorry, I'm just getting my
Okay.
tool.
Okay.
Um, so when you're considering an E2 reaction product, so it I remember that the octet cannot be full, right? And then the the alpha hydrogens determine stability, right? Or how much or substitution.
Mm,
So,
yeah,
are those the points that I should keep in mind?
yeah,
Doing this? Okay.
yeah. The substitution part.
Mm, mm, direct substitution. Oh, POCO3 is directly substitute. Okay, then OH leaves. Oh, okay. So then, wait, no, that's wrong. Wait. Uh, wait. Is that it? No. The OH leaves, right? Because the POCl3 bonds with the or attacks the carbon
See,
where the
whenever
OH
there is elimination reaction will proceed, the OH will remove. Okay, like dehydration
mm-hmm.
will proceed. So OH will remove, and in elimination there is always double bond will form,
Mm-hmm.
and you generate a double bond. So this is the one possibility of generating a double bond. Then there is one more possibility that is like this. Is this also a possibility? Hmm?
Mm-hmm.
Now, which is more preferable?
Mm, I'm looking through my notes. There's something about overfilling octets. I don't think any of them overfill the octet.
In which one?
I don't think any of them overfill the octet,
No.
so I don't think so.
Yeah, there is no any
Okay.
like, unstable.
Yeah. So then it would just be the substitution of it, or like I think that's the only thing I can see is the substitution of it. How substituted it is.
Okay. Yeah. So more substituted will be more
Mm-hmm.
preferable. Okay. So this is more
Yeah. Yeah.
substituted. So obviously this is more preferable, not this one. Okay. Very good.
Mm-hmm.
Okay. Now the next question. This one. This is the good question. Okay. Can you erase this part?
Wait, sorry, I'm just gonna write it down.
Okay, I'm writing here.
This is the preferred over the other one that I drew. Oh, that's the same
You
one
can
that I
direct.
drew.
You can only write down this one.
Oh, okay, okay, okay. Great, okay.
Okay. Now you try this one. J. What PBr3 will do?
PBR3. Let's see. Did you talk about this? Let's see. PBR3.
Hmm.
Br3. That's not an acid, right? So PBr3. It has to be. Wait, PBr3, is that similar to POCl3? No,
Uh,
right? It's different.
POCl3 is used for dehydration. Okay. And PBr3 is used to donate a Br minus.
Okay.
Br minus. And
Mhm.
PBr3 generally giving SN2 reaction. Now you tell me what will be the product.
Hmm. SN2, so that means that um SN2, so then it's going to attack on the VR will attack on the chiral carbon,
Yeah.
and then the leaving group will also simultaneously leave.
Yeah.
Okay. So then the BR will attach to the carbon on the right hand upper right hand side. I guess if you label that carbon one like carbon one, basically, like you bond there. And then OH would leave, which would cause inversion, right? So SN2 means inversion.
Yeah. That's the major thing which you needs to know.
Mm-hmm.
SN2 means inversion. Okay. Then
So that means the
which
configuration of the chiral carbon will change.
absolutely great. So at which position the is Br will attack on the chiral carbon? Hmm?
I thought it was a new. Wait. No, it's a nucleophile, right? Or no?
Yeah, Br
Yeah,
is
it's a
a
nucleophile. Mm, don't you need to attack a carbon that is chiral?
here is the car sorry, where is my okay, so here is the carbon which is chiral.
Mm-hmm.
Now tell me. Br will attack on this chiral carbon from the backside.
Mm-hmm.
Why from the backside? Because this is a type of SN2. Okay, backside, and this OH will removed. Okay.
Mm-hmm.
So what will be the product in this case? This one. Okay, and hydrogen will shift to the upward side, and here Br will come. Any doubt?
Oh, no, sorry. I thought you were asking me to explain why it's going to attack a chiral carbon or
No, no,
versus an achiral. Sorry.
no. Okay.
Because if you're not attacking a chiral, then there's no configuration of that. How do you even measure configuration, right? You need different groups.
Mm, yes.
That's why chirality is like one of the foundational topics.
Yes, chirality is very like important. Before going into organic reaction mechanism, we need chirality. Chirality or symmetry or
Hmm.
enantiomer bias stereomer,
Like the meso compound, yeah, enantiomer.
the product art.
So in these, there's no products here that are racemic mixtures, right? Or does it depend on the
Hmm?
like we haven't encountered anything that has a racemic mixture here?
No, in this case, we doesn't need about racemic mixture because our racemic mixture comes in the carbohydrate part when we discuss
Okay.
carbohydrate biomolecules. Now, so in that case,
Mm-hmm.
so now solve the K part.
Okay.
Give me a second.
Yeah, no worries.
Yeah, tell me what is the functional group in the K part?
Epoxide.
Great. And what type of reaction it is?
Ring opening.
Ring opening. Very good. And in ring opening, I describe you that there is two types of reaction. Yes or no?
Mm-hmm.
Yeah. So there is two possibility in ring opening reaction. So what was that? The first is in the acidic medium and the second is remaining all, which is not in acidic
Mm-hmm.
medium. Okay. So if the
Mm-hmm.
reaction is proceed through the acidic medium, then nucleophile attack at which position?
The nucleophile will attack an acidic medium. Okay, wait, I have notes on this. Acidic medium. It will be on the more substituted for
And
acidic, and then for anything else, it would be on the less substituted side.
great. Now solve this one, the K part.
Yeah, this is not an acid, right, at all.
What is this? This is potassium
Yeah. Potassium ox
methoxide.
epoxide.
Methoxide.
CH3.
OCS3. Methyl oxide, that is methoxide, we can also say. So it will converting into K positive and OCH3 negative, like this. Okay. Now this OCH3 negative attack on which direction? Or at A position or at B position? Tell me.
It's gonna attack on the less substituted B.
B, great. So it will attack on B. But there is a dilute H positive condition. So this is a acidic medium condition, I think.
Oh.
Oh, in that case, hmm?
In that case, then it would be more substituted.
But see, there is a acidic medium in the next step, like in the second
Yeah,
step.
yeah, yeah.
So, so that
Yeah, since
means the see when the KOCH2, that is nucleophile attack on less substituted side, because in the first step there is no acidic medium. So this will proceed
Mhm.
and this bond will break. So it will converting into O minus, and here will be OCH3 will come. Okay, and the K positive will attach to this one. Okay, O minus and K positive. After this, the second step, when dilute H positive will added, so in that case the K positive will removed. Okay, and this will converting into OCH3 and it will convert into OH, and like this. Okay.
Yeah, because I was like thinking, because I was hesitant to say that it's acidic because I don't think it is like a full-on acidic.
It is.
It is?
Yeah, but in the next step, like in the second step.
Oh, oh,
Yes.
e yeah, but that makes a huge difference, right? Because like in
Yes.
the first step, if it's
Yes.
not, then you can't really go into the more substituted side.
Mhm. Yes,
It's
that's
not
why we are not
stable.
going with more substituted side now. That's why we are
Mhm.
going with less substituted.
But if the it was also acidic already, then you would be able to already, what's it
Mm-hmm.
called?
Hmm,
Yeah.
yeah. But suppose if I'm not using the numbers like the 1 and 2, I'm just directly using that if I will use potassium methoxide KaOCS3 and in acidic medium. If I represent the reagent like this, okay, so in that case we will go with the less substituted, no, not less substituted, we will go with the more substituted part. Okay, so in that case, this will be the product over here like this and OCST will come. Okay, so if there is a acidic medium in the starting part is returned, so in that case we will go with this. Okay.
Hmm. This is if it's not dilute, like just H plus.
Hmm?
Sorry. For the second one, what did you mean to say? KOCH3 dash H plus or slash
So,
H plus?
so in the first reaction there
Mm-hmm.
is KOCST in the
Mm-hmm.
first step, and after that when the first step will completed, then we add a dilute H positive, like in acidic, like we are applying acidic medium in the second step. But let's suppose I'm applying acidic medium with KOCS3. That means like this is whole the one process. So in that case, what will be the product? That's what I'm asking.
Yeah, then it would add to the less more substituted, right? If it's
Yeah,
acidic. Mm-hmm.
yeah. If it is acidic, then more substituted will be the product. Okay.
But like, what did you mean? What my question is like, what did you mean to write here? Can you see what I'm?
That means I'm just explaining you what is the difference in between these numbers and if there is no.
Okay.
Okay.
Oh, okay, 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 okay. That changes the whole thing, right? The way you label it.
Yeah.
So anytime like with the reaction arrow,
Mm.
like when so if there are numbers like one, number two, that only indicates step, right? Steps.
That yeah, that we can say that there is steps, and also we can say that reactions. We can also say that let's suppose this compound with firstly react with this whole part, then after completion that the product will react with the second part. So in this reaction, epoxide firstly react with KOCS3. The whole epoxide will react with KOCA3. Okay, and after in the next step, we gonna do with the dilute H positive.
Okay.
Okay.
Okay. Okay, sorry, ma'am. I wanted to talk about something. So, I was looking into the professor's lecture videos, and I was trying to watch the lecture on infrared. What is it? Infrared?
IR,
No,
yeah,
IR
IR.
spectroscopy. I could not seem to really get like a handle on it. Like I didn't really feel like I understood it very well at all. And I
Okay.
think he covered IR and I believe NMR too. So like I was just
So,
like, yeah.
in case of IR and NMR, you need a lot practice, like a lot, and you need
Mhm.
to learn all the basics in them.
Okay.
Yeah.
Can
IR.
we go over?
Mhm.
No, go ahead. Sorry.
uh, uh, what is the difference in between IR and NMR? Why we are using that? So see, I already described you that what is IR and NMR in early stages of our classes. IR and NMR is basically what is the major use of them. So when
Mm-hmm.
let's suppose I am a scientist and I am a PhD scholar and I generate a compound, and now I wants to understand like. Where how many carbons in the compound, what sort of functional group will be formed, and like what is the exact compound I will form. So for to identify each atoms in the compound and each bonds in the
Mm-hmm.
compound, we are using
Yeah.
different spectroscopy. Spectroscopy is a sort
Mm-hmm.
of machines which are giving us
Mm-hmm.
some data. Okay, so let's suppose first we will talk about NMR. So what is NMR? NMR, there is two types of NMR. The first is hydrogen NMR, the second is carbon NMR. So to calculate where is hydrogen present in the compound, we use hydrogen NMR. Then to calculate the number of carbon and where the carbon attached and like how many bonds in between carbon and carbon. So in that case, we will go with the carbon NMR. Okay. So to hydrogen, it's hydrogen NMR. For carbon, it's carbon NMR. And there is one more, that is IR you are talking about. IR is used to
Mm-hmm.
identify the functional group. Okay, like in the organic
Mm-hmm.
compound which I discovered, is there any alcohol present, any ether, any epoxide, like what sort of functional group present. So on the basis of functional group we are identifying IR data. Okay, so that's what the major use of IR and NMR. Now, in exams, we need to identify. In IR is a little bit easier as compared to NMR, because in IR you only needs to learn the data. Let's suppose I have a 3-degree alcohol. So at which position I get a graph for 3-degree alcohol, I needs to know only that part. So let's suppose there is a peak
Mhm.
at 2870. There is a peak. Okay, that is a large peak on the graph. Then I'll identify from the data that at which type of functional group gives me that particular peak, like at
Mhm.
2870. So let's suppose in the data they will interpret that the alcohol, 2-degree alcohol will give that peak. So I can understood that there is a carbon which is a 2-degree and there is a alcohol group present on that. Okay, so that's the major use of the IR. Okay,
Okay.
if you want we can go with the IR and NMR. Like let's we solve half an hour on the organic reaction part and then the 1 hour for the spectroscopy part. If you want we can go with that also, that method.
Okay.
Because
No, I was just
yeah, because I'm able to see that
okay.
you are a little bit more confident in the organic reaction part. You know basic concepts really very well. And if you are having any doubts, the major part will coming from the spectroscopy. Then I think you needs to go with spectroscopy also. Okay, now
Yeah,
you tell
because
me.
it's a yeah. It's a completely hold on, let me double check because I'm not like completely enrolled yet. I'm gonna hear from my professor by next, but I think by Monday he'll let me know. But he did give he did like send me a syllabus. So
Mm-hmm.
I just want to double check what he covered. He covered organic reactions review.
Okay, so
Um that which
this
basically what we're doing. Yeah, and I sent you the worksheet, which is what we've been covering from yesterday. And then I believe okay. Let me see. What is his schedule? Okay, so on the 9th, he covered organic reactions review, and then on the 11th, he covered chapter 12 infrared spectroscopy, so IR.
okay, so IR is going on in your university, so we can go with IR
Mhm.
after that this part.
And then by next Wednesday, 'cause Monday's a holiday. Oh, Monday's a holiday, but by next Wednesday, we'll cover NMR.
Okay,
So, yeah.
so we'll go with IR after organic reaction mechanism if you want, or if you go reaction mechanism by yourself, then we can start with IR also from the next class.
Okay, yeah, I think a lot of these things are up in the air. There's no official like I can't it's hard for me to give you like a very set rigid like set of things
Mm-hmm.
to do right now because I'm not fully enrolled. But I do like know that he has these assignments where it's like you have to read the textbook, write like a 4 to 5 page sort of like a summary or something like that. So let's say like for infrared spectroscopy would be chapter 12 or something, right? I have to go and read the whole thing and then take like notes, extensive notes and stuff like that. So he's heavy on the textbook. He's heavy on the textbook,
Mm-hmm.
and he also has lectures, and there's usually quizzes on those lectures as well. So those are just some of the things that I wanted to let you know, just to keep in mind, I guess.
Okay.
But
Okay.
yeah.
Do you also have some reference or some textbook from university, like any particular reference book which your professor is using in the classrooms?
Yeah, so if you look at the syllabus, all the information about the class is there and like everything is there basically. Like it's a comprehensive overview of everything. I think the title of the textbook is
The Scam 2121207. This one? Organic
yeah, that
Chemistry, Spring 2026.
yes.
Okay.
The name of the textbook, I think it's Wade. Is it Wade? I think so, Wade. I think that's the name of it. I
Yeah.
think it would be very helpful if you took a
Mm,
look at it because I think a lot of our exams and everything assessments will be based on the textbook from what it seems. And his lectures are also based on the textbook. Because
yeah.
when I watched the lecture video, he uses these templates from the textbook to create the lecture. So I think it'd be useful to look through it.
Mm-hmm. There is
Just
like
like for the
five
coming future.
to okay, micro scale, microorganic experiments, spiral, non 200 pages, organic, molecular model set strongly. Okay, so there is two textbook he mentioned over here, Organic Chemistry ninth edition, Bedin Smith, and Student Solution Manual ninth edition. Okay, okay, so there is only one textbook now, which he
Mm-hmm.
gave to, okay. And the in your syllabus,
Mm-hmm.
there is not mentioned where is like NMR or IR.
Oh, if you go, you have to go all the way because it's like 12 pages. I know it's a lot of,
Okay,
it's very,
I don't know.
there's a lot of information. If you go to the very last page, ma'am, then you'll see the schedule of everything.
Yes, yes, yes. June 9, online lectures, on-campus laboratory. Holiday. Yes, yes. There is NMR, conjugated system, aromatic compounds, reactions of aromatic compounds. Okay, okay. Yeah, they are doing firstly IR, then
Mm-hmm.
NMR, then aromatic compounds, reactions of aromatic compounds, aldehydes, amine, carboxylic acids. There's a lot which we need to study about. Okay.
Yeah, but I wanted to like emphasize for you to keep the syllabus handy so that you can always come back as a reference. Then you won't feel like, like you have to always ask me because it'll just be there. Like you won't have to panic. Like you'll just have everything there to see.
Mhm. They also mentioned the number, chapter number.
Yeah, that's from the textbook.
Yeah,
Yeah.
it's ninth edition. Okay, great. Okay. So firstly, on Monday, 2 9 6 9. Mhm. Okay, so in your colleges, I think IR is completed, and from
Mm-hmm.
18th, like a piece on Monday or Tuesday, they'll start NMR part. Okay,
Mm-hmm.
so now I'm thinking that we needs to start with IR because
Yeah.
that is if you are with the college lectures, then it is helpful. Okay, we will
Yeah, of
start
course.
IR part. Okay, and that's the organic reaction part. You'll do by yourself, and if you are having any doubt anytime, then you can ask with me. Okay.
Okay.
Oh yeah.
Yeah.
From next class we will start IR. Okay. I'll check this
Mm-hmm.
textbook which is mentioned over here. Then
Yeah.
from that we
Yeah.
because that is like a compulsory to you also to study from that particular text. Okay, so we will start with IR next class. Today we will go with this part only. Okay,
All right.
can you please can you open the part over? Okay, let's. I will share this one. Uh, the organic reaction review. There is some reagents which is mentioned over here.
Mm-hmm.
I'm just describing you that what is the use of those reagents. Okay, then you will proceed with the reaction by yourself. Okay, I'm
Mm-hmm.
giving you homework like five reactions each day.
Okay.
Okay, so after like 4 to 5 days, you will completed these part. Five, no, five is very less. So I'll give you 10 questions. Like your homework for today is the second page complete, the complete second page on the PDF
Okay.
from organic reaction review work. Okay. Now you check the reagents and which reagents you doesn't know. Tell me.
Thus, and the second page.
Yeah.
Okay. Okay, organic reactions, right? From the second, right? Second page.
Yes.
Okay, so POCl3, pyridine we covered. HBr, HCl, I know those. Um,
So for the first is ZnCl2, zinc dichloride.
Mhm.
What is zinc dichloride?
don't HCl.
No.
or zinc dichloride. Is it a
Zinc.
salt or something?
Do you know about
No,
Lucas reagent?
I don't know
Lucas.
what I'm saying. Huh?
Do you know about Lucas reagent? There is a reagent like some Fehling reagent, Tollin reagent, Lucas reagents.
No.
Hmm? Okay, so ZnCl2 is used to identify. This is basically used for labs. ZnCl2.
Oh.
Okay, you can write down these part. But ZnCl2 needs to react. Needs HCl also. Okay, so ZnCl2 and
Okay.
HCl work together, and it is a Lucas reagent. This is used to differentiate 3-degree alcohol, 2-degree alcohol, and 1-degree alcohol. Okay, these are used to differentiate. Differentiate in 3-degree alcohol, 2-degree alcohol, or 1-degree alcohol. Okay. So how
Mm-hmm.
how they used to differentiate when let's suppose I am having a 3-degree alcohol and I put Lucas reagent on that 3-degree alcohol. So there is a turbidity, or we can say PPT will form in a 5 minute. Or
Mm-hmm.
you can say immediate. You can write down here immediately. Immediate. And if there is 2-degree, then it takes 10 minutes, 5 to 10 minutes. And if 1-degree, then there is no reaction. So see in the reaction, in the page number second, there is the 1-degree alcohol reacting with ZnCl2. So there is no any reaction will proceed in that case. Okay.
Because it's 1 degree? Oh. And then what is the other one? TSCl?
TSCl is tosyl chloride.
What
That
is
is
that?
TSCl is standing for tosyl chloride. Tosyl chloride. Okay. So
Mm-hmm.
this tosyl chloride that is TSCl. This is used to convert the OH group. Okay, let's suppose anywhere OH group. This will use to convert this OH group into OTS. Okay,
Mm-hmm.
tosyl chloride converting into TS positive and Cl negative. So there is OTS will form. Okay. Then what is the reaction? Tosyl chloride with pyridine. So there is TS will attach with the O group, okay, in the second reaction. Then there is HBr. So the C part is very good question, HBr. What is HBr? HBr is breaking into H positive and Br negative, okay. This is a type of substitution reaction again.
HBr?
Yeah. HBr, HCl, both of
Mm-hmm.
them are work as both of them are used for SN1 reaction.
Those are
Okay.
acids, right?
Yeah.
Okay.
Okay, so in the C there is SN1 or SN2? Tell me.
For which one? Numbers, or sorry, letter C.
Second on the second page, the size C.
Mm-hmm. That is going to be HBr SN1, right?
Yeah, SN1. Then in the D1, D. What is
Mm-hmm.
POCl3 and pyridine? What is the use of POCl3 and pyridine?
Substitution SN2.
Yeah. So in SN2 there is inversion will take place for OH. Okay.
Mm-hmm.
Then in E,
For epoxide
yeah. In epoxide, this is
opening.
ring opening. And ring opening in which condition?
If it's acidic, it'll be on the more substituted.
Yeah. And is it acidic medium or not?
It is acidic.
So it will go with the more substituted part. Then we will go with the F. Okay.
Mm-hmm.
In F,
Um.
in F
Oh.
and G, in F and G, in both case, the carbocation will form.
Mm-hmm.
Okay, and rearrangement will proceed, and with the rearrangement, the product will form with the SN1
Mm-hmm.
mechanism. In F and G both, SN1 mechanism.
Mm-hmm.
Okay, now talk about H. In H, there is tosyl chloride with pyridine. So what TSCl with pyridine will do? It will take the position of hydrogen in case of OH. So there is the whole structure remains same, but the TS will attach it to O. Okay, so OTS will be formed.
OTSL form.
Yeah, OTS will form in this case.
For which one?
In H,
Okay. Oh.
okay. Then I. In I, what is the reagent?
Wait. Sorry. For H, what is it gonna form? TS.
OTS will attach with like TS will attach with O.
Okay.
Yeah. Then in case of I, tell me.
It's gonna be SN2, right?
Mm, it can be SN1 or SN2 both because
Oh,
there is the same product. But
SN1. Oh.
but it will go with SN1 because HBr is there.
Mm-hmm.
Okay. If there is a PBr3 instead of HBr, then
PBR3.
yeah,
Then
instead of
it would be.
Mhm.
Oh, yeah. So it would be on the left, or it would be SN2.
Yeah, that will be SN2 if PBr will be there. Okay, then J. In case of J, when POCl3 in presence of pyridine, then
J, it's going to be. Oh, this one is gonna be SN2.
great. Then CH3OH in acidic medium. Now see this question. This is very important. Tell me what is the K? What is the process for K? Hmm?
For the process for K, it's gonna be um the it will. Oh, it's acidic, right?
Hmm?
It's not an acidic medium, so it will the
What is nucleophile here?
nucleophile is gonna be CH3OH.
Yeah, CH3OH is a nucleophile. And nucleophile is an acidic medium or not?
Yes,
Yes. So from which direction it will attack on the epoxide?
and it's gonna tack to the more substituted.
Then I. In
Mm,
case of I, what is the
CH
mechanism? HBr will be there.
SN1.
SN. Great.
Wait, what's CH3OH?
Methyl oxide.
Methyl
Methyl.
oxide. I don't really know all of these. I don't know why I don't know these like generic names. Or I don't know if they're generic names, like scientific names of these
Like I,
compounds.
because uh because you need to learn when you practice a lot of questions.
Yeah, I don't even know the names of these reagents though. Like, a lot of the thing maybe because I need more exposure, that's all.
Mhm.
Mhm.
Okay,
But
so
you have to memorize all of these names though, right?
yeah,
Okay.
I have
I
a
can
lot
also
of
Google.
experience in this, na. That's why.
Huh?
I have experience in this. Like I'm using these
Yeah.
compound in lab. So when we saw something in our labs, when we do some practicals, then the things are easily remembered.
Yeah.
But when we do only like practice or like that, so in that case, a little bit harder to remember. And I think you are doing these reagents for the first time. I think so. So that's why.
Yeah, it's been a long time since I took part one. I have like a huge knowledge gap. I don't remember a lot of these things, so
Mhm.
it's okay. I mean, I can just relearn them. It's not that big of a deal. I think
Yeah.
I can do it. I
Um,
think knowing these reagents is like the easier part.
Yes, knowing the reactions are easier, but the reaction mechanism is little bit
Wisdom is
hard.
harder.
Okay, so this is your homework, the second page, and after like in next class we will start with infrared part, IR part. Okay,
Okay, the next what
yeah,
pages? Next, like
the
page two?
second, yeah, page two.
Which one okay, so yeah, before are we almost done?
Yeah, if you are having any doubt, you can ask me because like for today we will done. You are getting your homework, and from next class we will start IR.
Oh, okay.
Okay.
Do you think that's better, like starting IR now, or like how much time do we have?
Yeah, needs a little bit time because that part is very new for you.
Okay.
You need
Yeah.
and to understood the concepts in detail. According to me, that is a little bit more easier if we know each concept rather than
Mm-hmm.
learning the part. Remembering is little bit harder. If we learn something, if we know some concepts related to them, then the questions are related to easier side.
Right. If you understand the logic.
Yes, yes.
Um, okay. Do you have any like questions for me, like in gen like for like
In
in
general,
terms of the course? Yeah, in terms of any sort of course information, like what you, I don't know if you need anything from me.
I go through with your syllabus when
Okay.
sir share that PDF with
Okay.
me. Okay.
Okay.
So in starting part, I thought that the syllabus is on the first page. I didn't go with the last page which you mentioned. Like for now, you mentioned me that the syllabus or your schedule on the last page. So I'll go with that now.
Okay.
Okay.
The
And
syllabus is like 12 pages though.
yes, yes, yes. I thought
Uh,
that the 12 pages is not for syllabus. That is like related to your homework. Your like it's basically a schedule for your whole session.
yeah, in America, that's how it is usually.
Yeah, yeah, yes.
Yeah. But
Hmm?
yeah, so I'm gonna also send you because I had a classmate send me some like she sent me copies of the textbook or like not a complete copy, but for the relevant chapters that we're covering now, and then also like there are some lectures that I saw on YouTube. My professor told me that he has lectures, so I can just view them there. Since like I'm not able to access all of the course information that other students are able to on the website. Like
Why?
we have a class because I'm not fully enrolled, so I don't have
Okay.
access to see
Okay.
everything.
Okay.
Right. So if like the professor makes an announcement or reposts something on the website,
Mm-hmm.
like we have like a student learning management website, like all the students in the college are on one platform. So they're able to see their course on a dashboard and then it has everything there. Like the modules,
Yeah, yeah,
all of
yeah.
the modules, all of the assignments are there. So I'm not able to see. So I'm like kind of relying on other people, but they were
Mhm.
able to like I had someone when I visited the class just to see like what the professor's teaching. Someone gave me some of the information, like she sent me the textbook, so I can send you the chapter for infrared spectroscopy if you want to see. And then also he has lectures on YouTube. I can also send you that one as well, like his lecture. Or I can send it to sir, and then he can give it to you.
Okay,
But
okay. But you don't
yeah,
need to worry. See, you don't need to worry if
okay.
Yeah, you don't need to worry about like how we'll study and all, because the portion, the chemistry is same all over, all over the area. You doesn't need to worry about like how your teachers, how your professor will taught you, because infrared is same. In the end,
Mhm.
you needs to know the concepts. The major thing which is
Mhm.
like you needs to know your concepts. If you know the
Yeah.
concepts, you can easily take over the students in the class.
Yeah, that's also true, but I think certain professors like to emphasize certain things in their tests. Oh, is she gone? Mm.
Lamia,
Mm-hmm.
I think ma'am got disconnected somehow. So,
Oh, okay. Well, she did mention that she's not going to teach anything to me anymore, like in this session, because